So I'm going to start by drawing a little diagram. This point will represent where they are at the beginning, and I'm going to mark where they need to get. Their destination is 2.4 kilometers south, 15 degrees west. Okay, so that'll be their destination. And I'll try to connect that with a straight line. Okay, so where have they gotten so far? So far they've gotten 1.6 kilometers. Actually, I should label the first line I drew, 2.4 km. And the angle here is, let's make it this angle here is 15 degrees. Okay, so how far have they gotten so far? 1.6 kilometers south, 30 degrees west. So perhaps a line such as that, 1.6 kilometers, and south 30 degrees west. So this entire angle is 30 degrees. So what we have to find out is what's left, what remaining displacement do they have? That would be represented by this blue arrow here. That's where they have left to go. So this turns out to be subtraction. What we need to find out is subtraction. If I call this, for example, I'll call this the second displacement, whereas I'll call the 1.6 kilometers the first displacement. Those two displacements added together have to equal to the total displacement, which I'll label as delta dt. So if I start writing out some equations here, so I'll say that the first displacement plus the second displacement will equal the total displacement. Then what I'm looking for is the blue line, which is the second displacement. And that can be accomplished by subtracting the total displacement minus displacement 1. So this is really a vector subtraction. So what I'm doing is the total displacement is 2.4 km south, 15 degrees west, minus the initial displacement of 1.6 km south 30 degrees west. So for subtraction, what I will do is change it to addition of the opposite vector. Okay, so change the subtraction to addition of the opposite vector. So I change south to north, change west to east. And then I can add these together in my vector calculator, online vector calculator. I have to get the angles worked out though. So the first angle of south 15 degrees west, that would be right here. So how many degrees is that if 0 degrees is east and we're turning counterclockwise? How many total degrees is that? Well, south is 270, and then I go backwards by 15 degrees. So it's going to be 225 degrees. Sorry, 255 degrees. The other one, north 30 degrees east. So start north, turn 30 degrees towards the east. That would point this way. But how many degrees is it if I start east at 0 and go counterclockwise to the line? It would end up being 60 degrees. So 60 is the angle I'm going to use in my calculator for the second one. So I've done that. I'll expand it. Or maybe I can't. Okay, so for some reason this is attached together here. So just try to expand it so you can see it for a second here. So I put in those values that I said, and it's coming up with the answer of 0.95 for the magnitude, and then 281 degrees for the direction. So I'll just write that down. 0.95 kilometers. And the direction was what was that again? 281 degrees. So what's 281 degrees? Just draw my grid again. So I know that 270 is south. And then, so 281, I've got to go past that by 11 degrees. So it would be south 11 degrees east. Okay, so that's what they still need to do. And that looks like it matches the diagram. It's going mostly south, but slightly to the east.